The purpose of today's video is to review the three subatomic particles and the properties of each of these particles. We're going to use our basic understanding of these properties to then write and analyze nuclear symbols and hyphenated notations. If we look at our representative particle, our atom, you'll notice that there are three different color-coded subatomic particles. These are the things that make up the atom as a whole. The first type of subatomic particle that we're going to focus on are the ones that are called protons. These are the ones that you see shaded in purple. The protons are in the center of the atom. This region is known as the nucleus, and the protons are positive protons. So the protons have a charge of +1. The mass or mass number of a proton is also equal to 1. That's 1 AMU, or atomic mass unit. This is not the actual absolute mass of the proton. Instead, it's the relative mass of the proton compared to other particles. As we already stated, the protons are located in the nucleus. And the protons are incredibly important because they actually identify the element that we're looking at. The number of protons is also known as the atomic number, and it's this number that is actually used when we organize our periodic table that we'll be looking at later. So when you see this whole number here, the 7 for nitrogen, that means that nitrogen has an atomic number of 7, which means every single atom of nitrogen will contain 7 protons. The next type of particle that we'll look at are these ones that are shown in blue. These are our neutrons. Now, neutrons are actually neutral. They are uncharged. They do not have a charge, but they do have a mass that's very similar to the mass of a proton. Because it's so similar, we actually also have determined its relative mass to be 1 AMU, or 1 atomic mass unit. Just like the protons, the neutrons are also found in the nucleus. But unlike the protons, you may have more than one number of neutron within atoms of the same element. Neutrons will help us determine what is known as the mass number of our element. But the mass number for each of the atoms within an element might be slightly different. If we add the number of protons and the number of neutrons together, we get the mass number. If we change the mass number by changing the number of neutrons within an atom, that new atom would be considered an isotope of the original atom that we had. Isotopes are same element but different numbers of neutrons, and since they have different numbers of neutrons, they have different mass numbers. Now, the importance of the neutrons could be thought of as it's what helps determine the mass number, but they have something else that they do that's pretty important. I'm going to say that these act like our nuclear glue, which makes us think that they really hold the nucleus together. Really, it's more like a buffer. If all we had in the nucleus were all these positively charged particles, we know that particles that have the same charge like to repel each other. So if we didn't have these neutral buffer zones, then the nucleus wouldn't be stable. The protons would repel the other protons and the nucleus would actually explode. So when we think about neutrons, we think of their importance as being the nuclear glue. The last type of subatomic particle that we have here are the electrons. The electrons are the negative particle. They have a charge of -1. They actually have a mass of 0 AMUs. And that's not to say that they don't weigh anything at all. They do have a mass. It's just so super teeny tiny that really it's negligible. It's so small we can kind of ignore it, which is why we do not include the number of electrons when we calculate our mass number. Because their mass number is technically 0, when we add it up, We don't include the electrons. Our electrons are the first things that are not found in the nucleus. These are actually found outside the nucleus. And you probably remember from previous lessons and other classes that we call these regions around the nucleus energy levels. So we can say that our electrons are found in energy levels outside the nucleus. The importance of the electrons are that they determine the reactivity. Or we can think of it as the chemical properties of the atom. If we compare the number of protons to the number of electrons, if we look at the difference between those two numbers, that'll actually help us determine the overall charge of the atom. If we have more protons than electrons, then we have a positive ion. A positive ion is also known as a cation. If we have more electrons than protons, we would have a negative ion. A negatively charged ion would be an anion. And if we have equal amounts of protons and electrons, then we would have a neutral charge overall. The protons and electrons, they would kind of cancel out, which means that there would be no net charge. Now, we use these understandings when we write our nuclear symbols in our hyphenated notations. And then, conversely, we can look at our nuclear symbol or hyphenated notation that's given to us and determine the number of protons, neutrons, and electrons from that information. So just a quick review, or maybe a preview. The nuclear symbol is going to contain a maximum of 4 different parts. This top area is where we write our mass number. Remember, the mass number is equal to the protons plus the neutrons. Sometimes you'll see it abbreviated with the letter A. So if you see a problem where it says A equals 20, that just means the mass number equals 20, which means the protons plus neutrons, the sum is 20. On the bottom here, we have our atomic number. And we already talked about how the atomic number was just equal to the number of protons. And remember, that's also the whole number that you'll find in each spot on the periodic table. In the middle is where we would put our letters. This is our symbol for the element, and this is the 1 or 2 abbreviation of the name of the element. And up here is where we would write our charge if there is a charge present. So just a quick review. To determine the mass number, we look at protons plus neutrons. To get the atomic number, we're just looking at the protons. And to get the charge, we can actually take the number of protons minus the number of electrons. If you have protons minus electrons and this number's bigger, then your overall charge winds up staying positive. But if you take the number of protons minus the electrons and the number of electrons was bigger, then your overall answer is minus, which would be your anions. All of this information can be determined if we know the protons, the neutrons, and the electrons for our isotope. We can also look at things called hyphenated notations. Hyphenated notations is actually the entire element's name. It's written out, so we wouldn't just use the symbol. If we had aluminum, we would write aluminum. We have a dash mark, or a hyphen, and then here is where we write our mass number. And remember, mass number is our protons plus our neutrons. Mass number is actually not found on the periodic table. Sometimes people get confused and think that the number underneath each symbol is the mass number, but that's actually an average of all the possible atomic masses for all the different isotopes of each element. So the mass number, while it's probably going to be close to that number, is not the same. The mass number is not on the periodic table, so please, please, please never try to identify an element based on the mass number. If you're trying to identify the element, you really should go back to the number of protons. Sometimes with this, you're also going to see a third area here where we could write the term cation if it's a positive ion, or anion if it's a negative ion. And sometimes you'll even see that they will specify which type. So they would say like +1 cation or -3 anion. This information wouldn't be there similar to how the charge wouldn't be there if we're looking at a neutral atom where protons equal the electrons. At this point, we're going to take a break. We're going to make sure that you absorbed all that information, and then we're going to look at the practice problems from the textbook. I would definitely advise that before you go on to the next video, you try the practice problems so that you can really use the discussion as a quick check of your work rather than trying to learn from it.